Intermediate Algebra Section 11.3 Geometric Sequences. In an arithmetic sequence, a certain number is added to each term to get the next term. When each term in a sequence is multiplied by a certain fixed number to get the next term, the sequence is geometric. Consider this sequence shown here. If we multiply each term by 3, 2 times 3 is 6, 6 times 3 is 18, and so on, the multiplier is called the common ratio because it is found by dividing any term by the preceding term. This is known as a geometric sequence. And here we have the formal definition. A sequence is geometric if there exists a number r called the common ratio, and in that example we just looked at, the common ratio was 3, for which we can find r by taking a term divided by the preceding term. Or we can express it this way: the next term in a geometric sequence is found by taking the preceding term times the common ratio for any integer n greater than or equal to 1. And let's take a look at an example then of a geometric sequence where they're asking us to find the common ratio. So we'll use that definition of a common ratio in a geometric sequence by taking a term over the preceding term. We have a division problem or a ratio, and when we divide here, 12 divided by 3 is 4. We can verify that 48 divided by 12, if we take the next term and its preceding term, we also get the common ratio of 4. This other example here, they're asking us to determine the common ratio, and using that same procedure, if we take a term divided by the preceding term, we have a negative divided by a positive is negative. The 0 would cancel out if we divide top and bottom by 10, and 4 over 16 reduces down to 1/4. We can see it easier here, just for verification. 10 divided by negative 40 would reduce to a negative 1/4 as well. When we're looking for a specific term in a geometric sequence, the nth term of a geometric sequence with a common ratio r is given by the following formula. A sub n is found by taking the first term, identified here as a sub 1, times that common ratio that we were just finding to the n minus 1 power for any integer n greater than or equal to 1. So in these next problems, they're asking us for a specific term. In this example, they want us to find the 8th term, so that would be our value of n. Our first term in this sequence is 1/2, and let's assume it's geometric, but we'll do a little testing just to be sure. And to find that 8th term, we do need to know the common ratio. So if we take 2 divided by the preceding term, we end up with a common ratio of 2, and if we verify that, starting right at the first term, 1/2 times 2 is 1, 1 times 2 is 2, and so on. It is a geometric sequence, and to answer this problem then, the nth term, the formula we just wrote down, is found by taking the first term times r to the n minus 1 power. Filling in the particulars then, for this specific problem, we have the 8th term is found by taking 1/2 times the common ratio, 2 to the 8 minus 1 power. It looks like we're going to have common bases of 2, so to simplify this, 1/2, which has 2 to the first power in the denominator, can be rewritten as 2 to the negative 1. Simplifying here, we have 2 to the 8 minus 1 or 7th power. We have common bases. That means we can add the exponents. So negative 1 plus 7 is 6. And if we simplify this, 2 to the 6th power ends up being 64. So the 8th term, and we have just the first 4, the 8th term out would be 64. In this next problem, they're asking us just to specify the generic nth term for this geometric sequence. We know the first term. That's pretty easy and straightforward. We need to find the common ratio. So if we take a term and divide it by the preceding term, we've ended up with a complex fraction, but we can express this as the numerator divided by the denominator. When we divide fractions, we can invert and multiply, so we end up with negative 1/25 times the reciprocal of 1/5, which is 5/1. We have a negative times a positive, which is negative. We'll end up with a negative 5/25, which reduces to a negative 1/5. Now we can find that generic nth term. The nth term is found by taking the first term, which we found it to be 1/5, times our r, which is negative 1/5, raised to the n minus 1 power. We have common bases here, so we can clean this up a little bit, but we do have this negative 1 in here. So before we combine our common bases of 1/5, let's pull the negative 1 from this term. So actually, this would be a product in here of 1/5 raised to the n minus 1, as well as the negative 1 raised to the n minus 1. If you put these two together, raised to that n minus 1 power, you see we have the negative 1/5. And what this allows us to do, now we have our common bases. We have 1/5 to the first power times 1/5 to the n minus 1. Common bases, add the exponents, 1 plus n minus 1. The 1's cancel out, so we end up with 1/5 to the n power, and to accommodate that alternating negatives, because of the ratio being negative, we have to have negative 1 to the n minus 1. So our final answer for the nth term is the following.